All right. Hi, everyone. Good morning. Yeah, good morning, Aravir. Good morning, Sneha. Hi, Anjali. Good morning. Oh my God, that's a tough name. Smruti Rupa. Good morning, Smruti. It's okay, right, if I use the shorter version? All right. Good morning, everyone. So, long time. I think beach mein you guys had a good dosage of physics and maths ke lectures. So it's been a while since we talked about atomic structure chapter. I hope you guys were able to do a quick recap of what we have studied in the previous lectures. And assuming if there are any new participants in today's batch, right, those students would have been able to get access to the lecture PDFs and recordings. Great. Right. Are there any new students in today's discussion? Those who are attending for the first time. All right. Athar, have you received the lecture recordings? Previous couple of lectures that happened. Okay. Good. Not a problem if you guys are attending today for the first time. Also, it's not really a big problem as such. We are in the beginning part of the chapter only, and as a quick recap, आप लोगों ने like you know वीडियो लेक्चर्स देखे होंगे तो आपको एक आइडिया लगा होगा that we have done the initial bit, and हाँ मैंने आप लोगों को थोड़ा questions try करने के लिए दिया था from the booklet itself. So right, I hope you guys are making notes as well, right, from the lecture recordings as well as the notes that I'm sharing with you. Don't rely on कि सर ने भेज दिया तो print out निकाल लेंगे, right? Please make your own notes. Like I am making those notes for you, but I would like you to also have them handwritten by yourself so that future reference के लिए it becomes much easier for you. Great. So okay, assuming most of the students have joined in, let's pick up from where we left in the last class. And as a quick, recap of the theory of light also, that is where I have this quick video with me. I will share with you in a while once I, ask you to go through. In fact, if most of the students have joined in, then I can quickly, talk about this video as well. So it's an interesting video. ये NASA का ही created video है on electromagnetic waves and electromagnetic radiation. So given the earlier background in which Newton proposed the particle theory of light, it was later when James Maxwell, in fact, बीच में भी, like we talked about the properties of wave nature of light through Young's double slit experiment and all of that. And in fact, later around 1870s is when light was then considered or understood as electromagnetic waves or electromagnetic radiation. तो इसके बारे में हम लोगों ने लास्ट क्लास में जस्ट थोड़ा बहुत एक डिस्कशन किया था, right? This was the part that towards the end of the lecture that we talked about, that when an electrically charged particle moves under acceleration, right, alternating electric and magnetic fields are produced and transmitted, right? These fields are transmitted in form of what is called as electromagnetic wave or radiation, right? So now as a quick recap, and some additional piece of information about electromagnetic waves and electromagnetic radiation. I'm sharing this video with everyone. ठीक है, आई होप आप लोगों को जूम के चैट ऑप्शन में मिला है ये वीडियो. कैन यू गाइस क्लिक ऑन दैट लिंक? हाँ, तो 5 मिनट का वीडियो है, छोटा है बट काफी इंफॉर्मेटिव एंड काफी अच्छे से बनाया हुआ वीडियो है. स्पेंड दैट 5 minutes एंड देन कम बैक एंड देन वी विल अंडरस्टैंड क्या क्या चीजें हमें याद रखनी है. ठीक है, फॉर दोज हु हैव जॉइंड इन जस्ट नाउ, please watch this video. I'm sharing it on the chat for those who are joining in just now. In fact, there are more and more students who are joining in a bit late. For everyone who has joined in late, please, I'm resending this video ka link. Quickly go through this link and then come back in 5 minutes or so. It's a 5 minute long video only. No, you don't need to leave the meeting. You just need to switch over to that YouTube ka tab. For anyone who has joined in late, I'm sharing the link to this video on the chat. Please go ahead and watch this 5 minute video. It will be a quick recap of what we had, talked about wave theory in the last class and some additional piece of information that we are going to talk about in today's class. For those students who have joined in late, I'm still seeing some students who have joined in late. Please go ahead and watch this video. I'm sharing it again on the group. In the chat box. It's a 5-minute video. All right, those who have watched it, good. कैसा लगा वीडियो गौरव आपको? गुड गुड. नहीं नहीं प्रकाश ऐसा नहीं है that UV rays travel more than gamma rays. UV rays have a greater wavelength. That's it. In terms of traveling, like these waves just keep on traveling unless they are encountered by an obstacle. Good. Now, as an interesting anecdote to this, like I hope now you can appreciate something more. So, right now, all the information, all the knowledge about things around us, okay, most of that knowledge is based on understanding of electromagnetic waves and electromagnetic radiations, right? Like around us, the stars, the planets, like in सबके बारे में जो भी piece of information we have been capturing is via the electromagnetic radiations. Now, you can also appreciate a new field of science that has evolved, that has emerged because of gravitational waves. Now, gravitational waves is something which is a very, very new concept that has come across us experimentally. It was predicted long back, but it is experimentally confirmed like a year back only, a year or two back. And that will open a new frontier of understanding the universe around us. अभी तक जितनी अंडरस्टैंडिंग है हमारी वो सब इलेक्ट्रोमैग्नेटिक वेव्स या इलेक्ट्रोमैग्नेटिक रेडिएशंस पर बेस्ड है. So let's see what new things are going to come up with the discovery of these gravitational waves also. सुना होगा ना आप लोगों ने? Have you guys come across this term gravitational waves? At least those who are curious would have come across. अभी थोड़े टाइम पहले ही लाइक डिस्कवरी हुआ था ग्रेविटेशनल वेव्स का. Good, good. So we have a bunch of curious people amongst us. Really nice to see. हाँ मुझे भी ज़्यादा नहीं पता है. If you are expecting me also to know much about gravitational waves, I'll be honest, I also don't know much. Like it is definitely something to look forward to. ठीक है. Good. So आप लोग बाद में फ्यूचर में आप रिसर्च करोगे तो you will have this area of research in which you guys can go. Right. Coming back to our syllabus, coming back to the things at hand, right? हम लोग लास्ट क्लास में थ्योरी ऑफ लाइट डिस्कस कर रहे थे एंड थ्योरी ऑफ लाइट में मैंने आपको बताया था to start with that it was proposed by Newton that it is made up of particles, but then with the Young's double slit experiment and Thomson-Huygens experiments we understood that light has wave nature. And then Maxwell in his theory of electromagnetism was able to talk about the origins of light, that what light exactly is, and he presented that light as an electromagnetic wave or electromagnetic radiation, which is these alternating electrical and magnetic field produced and transmitted. That is what electromagnetic radiation is. So इसको ज़्यादा डेप्थ में तो हम लोग स्टडी नहीं करेंगे, जस्ट एक सिंप्लीफाइड वर्जन ऑफ इट्स प्रॉपर्टीज ये हम लोग जरूर देखेंगे, राइट. एंड इसमें ये कुछ 2-3 पॉइंट्स हैं, some simple properties which again I would like you to remember from the syllabus perspective, right. जैसा आपको बोला था that you have a source, right. What was the source? Source was this electrically charged particle under acceleration, right. This was your so as to speak the source, ठीक है. एंड यहाँ से इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड निकल रहा है, एंड बिकॉज ये डिस्टर्ब्ड है, लाइक वी से दैट इट इज ऑसिलेटिंग, तो ये इलेक्ट्रिक फील्ड भी ऑसिलेट कर रहा है, ऐसे represented by this waveform, ठीक है. This is for the electric field, and with this electric field there is a magnetic field that is also generated, which is perpendicular to the electrical field, ठीक है. सो ये परपेंडिकुलर उसके रिप्रेजेंटेशन दिखाई जा रही है यूजिंग दिस x, y and z coordinates, and the direction of propagation, right, the way in which these electric and magnetic fields are traveling, इसका डायरेक्शन इन दोनों फील्ड्स के डायरेक्शन के भी म्यूचुअली परपेंडिकुलर रहता है, ठीक है. अब ऐसा क्यों होता है? दिस इज समथिंग व्हिच इज अ मोर detailed question to be explored. However, right now we don't really want to get into the details of what electromagnetic waves are at a fundamental level, what electric field and magnetic field is, because it requires a lot of background. It's just this property of electromagnetic waves which is mentioned in NCERT, so I want you to also be familiar with it, right. So you have this electric field, right, and you have this magnetic field, right, and they are present in a perpendicular manner and propagating to the direction of propagation, like this axis, you can say this is direction of propagation of wave. ये तीनों म्यूचुअली परपेंडिकुलर रहते हैं, ठीक है. ऑल राइट. हाँ, बोलो श्रवण.
Yes, sir. Sir, Maxwell said that the light is an electromagnetic wave, right? So it should be made of particles, because only a charged particle can produce electric and magnetic field, right? So in that way, light is has particle nature.
Okay, so well, we are going to talk about quantum theory of light, in which light is going to be shown or have particle nature. हम लोग करेंगे वो discuss, but not exactly in this way, like the way in which you talked about it. उसके पीछे के experimental background, experimental evidences करेंगे हम लोग.
Okay, sir.
हाँ, बोलो गौरव.
Sir, isn't it that we'll discuss it about how light behaves as photons,
हाँ,
as packets of energy?
Right. We are going to come to that.
Yes.
हाँ, बोलो तौसीफ.
Sir, over here it says that the electric and magnetic fields is always perpendicular to each other. So then how can one charged particle vibrate in two different directions at the same time?
नहीं, that is what I said कि ये जो एस्पेक्ट है ना, ये थोड़ा सा ट्रिकी एस्पेक्ट है. मतलब this is not something which is like आपको अभी electric field ही नहीं पता है अच्छे से, आपको magnetic fields भी नहीं पता है अच्छे से. So I am kind of jumping a lot of science to just come up with this statement in front of you. But that is something which I would want you to just remember. Okay, I would not want to let go of this point because of the fact that we can't go into the details of it, as well as like we can't really explore what electric field and magnetic field is right now to start with. But I would like you to remember this point from future reference perspective also, that as a property, ठीक है, हम लोग यहाँ पे properties discuss कर रहे हैं of electromagnetic wave. So as a property, ये आप यहाँ पे ध्यान रखो that in electromagnetic wave, the oscillating electrical and magnetic fields are perpendicular to each other. ठीक है, that's it. Then couple of other properties which you need to remember are of this nature, that these electromagnetic waves, they do not require a medium. They can move in vacuum, right? Also, these electromagnetic waves have different wavelength or different frequencies, and a collection of them is what is called as an electromagnetic spectrum. And another important point to notice is that all these EM waves, like all these electromagnetic waves that are of different wavelength of frequency, are going to travel with the same speed in vacuum, right? And we call that as the speed of light. You should remember the value also. And ये formula हम लोगों ने last class में discuss किया था, that speed is equal to frequency into wavelength रहता है for any traveling wave. So this is also a result to be remembered. And another property is that these electromagnetic waves, they are not affected by an external electric field or magnetic field, right? जैसे आप लोगों ने cathode rays के बारे में पढ़ा था या एनोड रेज के बारे में पढ़ा था, तो दे वर मेड अप ऑफ दीस पॉजिटिवली चार्ज एंड नेगेटिवली चार्ज पार्टिकल्स, जिनके अक्रॉस अगर हम इलेक्ट्रिक फील्ड या मैग्नेटिक फील्ड लगा देते हैं तो दोज रेज दे डिफ्लेक्ट, राइट? बट दीज इलेक्ट्रोमैग्नेटिक वेव्स, दे आर नॉट डिफ्लेक्टेड बाय एन एक्सटर्नल इलेक्ट्रिक और मैग्नेटिक फील्ड, राइट? सो दीज आर सम की पॉइंट्स टू बी रिमेंबर्ड. हाँ, बोलो देवांशी.
The electric and the magnetic field which is created around the electromagnetic wave is their own, and if there's an external one, then they are not affected by it.
Like for example, आपके रूम में भी जो light आ रही है from whatever source that is there, like, and if you like place a strong electric field or magnetic field, it will not bend that light. ठीक है, हाँ, बोलो श्रवण.
Sir, different electromagnetic waves at different frequency and wavelength. So how can they travel in with the same speed?
So right, there's frequency and wavelength. They are proportional the speed. So यहाँ पर अगर frequency किसी की ज़्यादा होती है किसी वेवलेंथ की, तो उसकी एज इन किसी रेडिएशन की, तो उसकी वेवलेंथ कम रहती है.
Okay sir, got it.
जैसे वीडियो में आपने देखा होगा ना, इनफैक्ट आई एम जस्ट गोइंग टू टॉक अबाउट दैट एज नेक्स्ट पार्ट ओनली, like wherein I am going to ask you to remember certain key piece of information from electromagnetic spectrum. क्या क्या key piece of information है वो आप एक बार यहाँ पे नोटिस करना, right? So when we talk about electromagnetic spectrum, इसका एक बेसिक डेफिनेशन क्या हो गया? इट इज द कलेक्शन ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन ऑफ डिफरेंट वेवलेंथ्स और फ्रीक्वेंसी, right? What I would like you to remember from this is the names of these different radiations that we have, right? And their relative order in terms of energy or frequency, right? So you have यहाँ पे नोटिस करना सबसे लो एनर्जी के रेडियो वेव्स, right? These are of lower frequency, or you can say higher wavelength, right? And when you talk about say gamma rays, right? Gamma rays या cosmic rays जो हम बोलते हैं, right? They are the ones with higher frequency, ठीक है, or you can say lower wavelength, right? In that video, like बहुत ही अच्छे से वो चीज का एक quick animation दिखाया गया था, like energy के perspective से. Imagine like if you have like a rope in your hand and you are using that rope to create waves, and अगर आप कम energy use करके वो waves create कर रहे हो, तो like वो ऐसे रहेंगे, इनकी wavelength ज़्यादा रहेंगी, frequency कम रहेंगी. But like at the same time, if you have the same setup and you like try to create these waves with higher energy, right? आप ये rope को fast ऊपर नीचे करोगे, right? So what you will generate is a wave which has lower wavelength, right, and a higher frequency. So उसी like analogy से you can also remember how these waves and their frequency and wavelength are related. So इसमें आपको क्या क्या याद रखना है electromagnetic spectrum में? Like you need to remember the names of the different groups that have been created in the spectrum. So radio waves, then followed by microwaves, right, followed by infrared, right, इनको short में हम लोग IR भी बोलते हैं. Then you have visible rays, right, followed by ultraviolet, short में UV भी बोलते हैं इनको, and then X-rays. ठीक है, so ये relative order of different radiations आपको ध्यान में रखना है. Number one, that is one thing to remember. Second thing to remember is that किसका frequency कम किसका ज़्यादा, that is also to be remembered. Then another thing that you need to remember is the details inside the visible region, right? आप लोगों ने already junior classes में पढ़ा होगा that inside the visible region the wavelength का range, ठीक है, बाकी सबका भले याद रखो नहीं रखो, बट विजिबल का रेंज एंड अप्रोक्सीमेट रेंज है ये 380 नैनोमीटर टू 760 नैनोमीटर रहता है. ठीक है, समटाइम्स इट इज लाइक अप्रोक्सीमेटेड एज 4000 एंगस्ट्रॉम टू 8000 एंगस्ट्रॉम. That's also okay. You don't need to be very hard and fast in terms of remembering the values. Just एक range का आपको idea रहना चाहिए that this is the range of the wavelength that we see in the visible region. And within this, like you should also remember the way in which they are present, the different colors are present in terms of their frequency. So violet has a higher frequency, right? Red has the lowest frequency, right? So this has the again I would say higher frequency. In fact, I'll just copy paste this thing only. This is the one which has the higher frequency, and red is the one which has got higher wavelength, lower frequency. ठीक है, ये एक आपको समरी इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम की याद रहनी चाहिए, राइट, फ्रॉम द पर्सपेक्टिव ऑफ व्हाट कैन बी आस्क्ड इन द एग्जाम. ठीक है, बाकी वो सब फैंसी एग्जांपल्स एंड ऑल आर आउट गुड इन द वीडियो. दिस इज at least this much you should remember. We can discuss one or two doubts. Bolo Prakash.
Sir, good morning, sir.
Good morning.
Sir, I have a doubt, sir. When we are taught that like charges repel and unlike charges are attracted, sir, so if electric field or magnetic field is introduced in front of EM, hello.
नहीं समझा नहीं मैं, आप दोबारा रिपीट करो.
Sir, if a charged particle like electric field is introduced in front of the EM wave, sir, so it should get deflected.
नहीं पार्टिकल पे इफेक्ट होगा. वी आर नॉट सेइंग कि पार्टिकल पे इफेक्ट नहीं होगा. हम लोग बात कर रहे हैं यहाँ पर इलेक्ट्रोमैग्नेटिक वेव्स के बारे में. ये इलेक्ट्रोमैग्नेटिक वेव्स जो हैं दे आर नॉट इन्फ्लुएंस्ड. लाइक फॉर एग्जांपल यू हैव अ सोर्स जिससे अब इलेक्ट्रोमैग्नेटिक वेव निकल गई है, ठीक है, एंड वो इलेक्ट्रोमैग्नेटिक वेव प्रोपगेट कर रही है. अब आप उस इलेक्ट्रोमैग्नेटिक वेव के अक्रॉस इलेक्ट्रिक फील्ड या मैग्नेटिक फील्ड लगाओगे तो दैट इलेक्ट्रोमैग्नेटिक वेव इज नॉट अफेक्टेड. दैट इज व्हाट आई एम टॉकिंग अबाउट.
Okay, sir. Okay, sir.
हाँ, बोलो अदिति.
Yes, sir. Sir, in the first property we did,
You said that the electric field, the magnetic field, and the direction of the propagation is perpendicular. So when we talk about the fields, the trough and the crest will be like will have the least strength, right?
Okay, so you are getting into the details of what is electrical field and what is magnetic field, right? So, so that is where I said ki it is like a good point for you to explore in future. But right now, because we don't want to get into the details of what is electric field and magnetic field, because this itself are separate chapters in physics, that what is charge, right? What is electrical field, what is magnetic field, right? These fields, what is their magnitude, what is their direction. So all those things are something जिसका क्या है हम लोगों ने background पढ़ा नहीं है अभी, तो उसके ऊपर डिस्कशन करना is sort of a little going to be a risky thing. So that is where I do not want to be discussing that as part of this class. हमारा focus थोड़ा अलग है. उसमें एक point आया था which I would want you to remember. That's it. ठीक है. All right. हाँ नहीं आपको इस तरीके से हाँ बोलो आदित्य.
Yes, sir. Okay, sir, I got that. But the propagation is perpendicular to it, right?
हाँ हाँ ये तीनों mutually perpendicular रहते हैं. That's it. Like the direction of propagation, the electrical field and the magnetic field.
Okay, sir, got it. And sir, for the electric and magnetic fields, when we say that the wavelength frequency, all of it will be equal. So technically, if we displace, like if we try to displace the magnetic field perpendicularly, they will essentially be the same, right?
मतलब this is what the fourth law that Maxwell's equation was, that electrical currents create magnetic fields and changing electric fields create magnetic fields.
Yes, sir.
True.
Thank you, sir.
ठीक है. हाँ. All right. अब थोड़ा सा आगे बढ़ते हैं. So based on this, like as a quick recap of the theory of light that you understood, let me now move towards the quantum theory of light, and the journey towards the quantum theory of light is also quite interesting. So यहाँ पर let me talk about the background before we get into the quantum theory of light. So what happens is यहाँ पर आप notice करना that around the end of 19th century, there are these certain experiments that are not satisfactorily explained by the wave theory of light. What are these experiments? आप notice करना, or around I should say the end of 19th century. Certain experiments were not satisfactorily explained by this wave theory of light. क्या थे ये एक्सपेरिमेंट्स एक बार आप नोटिस करना. सबसे पहला रहेगा ब्लैक बॉडी रेडिएशन. क्या होता है हम लोग इसके बारे में एक ऊपर से बात करेंगे. दैट व्हाट इज ब्लैक बॉडी रेडिएशन. Photoelectric effect will be the second one. Atomic spectrum will be the third one, and the fourth one would be heat capacities of solids at low temperature. Now अब बैकग्राउंड समझने की कोशिश करना that what is going to be the way in which things progressed. So this was around 1870s, right? This was around 1870s when, Maxwell proposed his theory of electromagnetism. Around 1890s, ठीक है, उसके पहले तक, like this wave theory of light, this was a well established theory. Like people at that point in time had even thought of it that like Maxwell ने like physics की research खत्म ही कर दी है. In the sense, he has given this theory of electromagnetism, which now almost explains everything around us. However, around this time only, around 1890s, there was this, in fact, there were these couple of experiments that came across, such as black body radiation, photoelectric effect, like जिनका explanation wave theory of light से नहीं आ रहा था. ठीक है, what do I mean by that? What do I mean by that is simply that जो experimental observations आ रही थी, ठीक है, and जो theory के predictions थे, experimental observations and theory के predictions, they were not matching with each other. कैसे? We will talk in some details about each one of them. Not the last one, at least. Last वाला थोड़ा सा out of syllabus है. But पहले दिन के बारे में हम लोग थोड़ा discussion करेंगे. That why this theory and experimental observations were not matching. Now, अब इसके पीछे की एक interesting story कुछ इस तरीके से है. ध्यान से सुनना. That it was Max Planck, ठीक है, another great scientist, who was able to explain black body radiation by modifying the wave theory of light. He modified the wave theory of light and introduced his own set of assumptions. Now, at that point in time, Max Planck ने assumption ही लिया था. Like he did not have a firm theory behind his assumptions. In fact, what he did was more of a mathematical manipulation. He said that wave theory तो explain कर नहीं पा रही है black body radiation experiment को. तो he said कि अपन लोग करते हैं ना लैब में कई बार ऐसे डेटा ऑब्जर्व करते हैं और फिर डेटा से like relationship, mathematical relationship draw करने की कोशिश करते हैं. तो वैसा ही टाइप मैक्स प्लैंक ने किया था. Like he got hold of the experimental observations which were not matching with the theoretical predictions. So what he did was that अगर इनको match कराना है तो एक ये कुछ assumption लेना पड़ेगा. And he took that assumption and explained black body radiation. ठीक है, around 1890s में कहीं पर. However, the assumption which he took, like this assumption that he took, was not well accepted by the scientific community. Right? Again, his assumption was looked with a lot of skepticism. कि ऐसे कैसे आपने कुछ भी assumption ले लिया. And in fact, Max Planck, like Max Planck की biography जब अगर आप कुछ उसमें से lines वगैरह read करते हो तो उसमें Max Planck का खुद का statement यही रहता है कि he himself was not sure. He was like कि I did math, but how to explain that, how to make sense of it was not himself. He was very confident of it. He himself was a bit skeptic on the assumptions that he took. However, it was able to explain this black body radiation. Now, what happens? ठीक है, at that point in time, Max Planck का theories अपनी जगह रख देते हैं, but the scientific community is like कि नहीं ये सब हम लोग नहीं समझेंगे. It is not something which is like well validated through experiments. However, some years later, ठीक है, around if I remember correctly, like 1901 से 1910 के around is when these experiments also emerge, which are not getting explained by wave theory of light. Now, what happens is that Einstein and Niels Bohr, they use the same assumption that was provided by Max Planck. And they use that assumption to explain photoelectric effect, atomic spectrum, as well as आइंस्टीन ने ही लाइक ये चौथा वाला एक्सपेरिमेंट भी एक्सप्लेन कर दिया. So it was later when Max Planck का assumption was used by other scientists independently to explain these other phenomena which were not being explained by the wave theory of light, is when Max Planck got recognition. Max Planck's theory got recognition. And many years later, in fact, I think 20 years later or so, is when Max Planck was awarded Nobel Prize for his assumption, which is now called as the quantum theory of light. So इसकी काफी interesting story रही है, in the sense that how himself Max Planck was not sure about his assumption, but later on it was used by Einstein and Bohr to explain these other observations which were not being explained by wave theory of light. So एक एक करके चलते हैं अब इसमें. ठीक है, सबसे पहले हम लोग बात करते हैं ब्लैक बॉडी रेडिएशन के बारे में. ठीक है, एंड इनफैक्ट बिफोर आई बिगिन, लाइक आई विल जस्ट गिव यू अ क्विक कॉन्टेक्स्ट दैट हम लोग ब्लैक बॉडी रेडिएशन का एक सुपरफिशियल अंडरस्टैंडिंग डेवलप करेंगे. ठीक है, इसका सुपरफिशियल कवरेज रहेगा बिकॉज the math required for it will be something that you will cover in that you will cover in class 12th का physics. ठीक है, तो इसमें हम लोग mathematical aspect नहीं देखेंगे, just एक you can say qualitative aspect observe करेंगे. So mathematical aspect, this will be in class 12th physics. ठीक है, photoelectric effect and atomic spectrum. This is something which is going to be really important. ये हम लोग इसी चैप्टर में डिटेल में कवर करेंगे. We will not just understand them like subjectively, qualitatively, but we will also understand them mathematically. इस पर बहुत सारे numericals और all भी रहेंगे. Heat capacities of solid at low temperature. This is something which will be OOS. OOS stands for out of syllabus. So we are not going to get into this fourth one. It itself is a bit tricky, like interesting, but not something which we'll be doing as part of our syllabus. So एक एक करके अब हम लोग आगे बढ़ते हैं. Let me talk about the first one, which is black body radiation. Now, as part of the video जो आप लोगों ने अभी start of the lecture में देखा था, राइट, उसमें से एक इंपॉर्टेंट टेक अवे आपके सामने ये आया होगा दैट ऑब्जेक्ट्स अराउंड अस emit and absorb radiation, राइट. हाँ आदर्श, हम लोग आएंगे फोटो इलेक्ट्रिक इफेक्ट आएंगे, तब मैं उसके एप्लीकेशंस एंड ऑल भी डिस्कस करूंगा आप लोगों के साथ में. However, अभी पहले एक बार ब्लैक बॉडी रेडिएशन के ऊपर फोकस कर लेते हैं. So when we are talking about that video जो आपने start of the lecture में देखा था, you guys understood that all objects around us, right, emit and absorb radiation, right. Sometimes the emitted radiation is actually a reflected radiation. Sometimes it could be it itself could be a source of radiation, right. So यहाँ पर notice करना that certain objects can emit and absorb almost all frequency or wavelength के radiations. Certain objects emit or absorb radiations over a wide range of frequency or wavelength. Such objects are called as black bodies. Now, what could be an example for it? So, don't go with the name that black bodies मतलब काली दिखेंगी, ऐसा नहीं होता है. The reason why they are being called black bodies is because of the mathematical, or not mathematical, actually the scientific definition of they being able to absorb all wavelengths and all frequency के radiation. इनके examples कैसे रहेंगे? For example, sun is an example of a black body radiation. Okay, it's a black body. It is emitting wavelengths of all. It is emitting electromagnetic radiations of all wavelengths as well as absorbing them. Right? You have various other stars. Right? In fact, metals heated or metals at high temperature, I would say, they also behave like black bodies. Like they will be emitting radiations in a very large range of wavelength or frequency. Okay, हाँ बोलो अथर्व.
Sir, why have you so-called or considering the definition of black bodies?
Why aren't they what?
Why have you so-called or after writing wavelength or frequency or wavelength?
हाँ मतलब like आप frequency के term में बोल लो या wavelength के term में बोल लो, like that's just talking about how you want to talk about the electromagnetic spectrum. ठीक है. हाँ.
Sir?
हाँ.
Sir?
हाँ.
I had a doubt whether these objects they will emit and absorb radiations over a wide range of frequency, or only emit or only absorb.
नहीं, both. They emit and absorb.
Okay, sir.
In fact, good that you pointed out. I will not use a slash. I will rather use emit and absorb. हाँ. बोलो शालू.
Yes, sir. So, our sun emits gamma rays, ultra rays, infrared, all the rays which we see around us, right?
Right.
And it also then sends the visible spectrum of a Vibgyor.
Right.
Okay, sir. Got it.
हाँ. बोलो आरवीर.
सर कोई ऑब्जेक्ट वाइड रेंज का वेवलेंथ और फ्रीक्वेंसी दोनों सेम टाइम पे अब्सॉर्ब या एमिट कर सकता है?
हाँ
या
हाँ.
दोनों में से कोई एक ही करेगा?
हाँ हाँ. जैसे सन है ना, तो सन के अंदर like we have these atoms or of hydrogen and helium which are at high temperatures, and they can be absorbing radiations as well as emitting radiations, and the range in which they do so of frequency or wavelength is a large one, like it's a very wide one. तो उसमें सारी frequencies and wavelengths cover हो जा रही है almost.
Okay.
ठीक है. हाँ बोलो श्रेय.
Sir, do these radiations include radioactive radiations like alpha and beta or no?
नहीं. These are
Okay,
not
sir.
radioactive.
Only electromagnetic.
Yes. हाँ बोलो गौरव.
Sir, these processes take place simultaneously, the emitting and absorption of radiations.
हाँ. Like because it's a vast collection of atoms now. So some atoms can be absorbing, some atoms can be emitting, and like
Sir,
overall.
and does this cause like because there is absorption of energy? You told in one of the previous lectures that electrons can be excited. Sir, so is it possible that electrons will be emitted?
वो भी हो सकता है. Electrons can be ejected also.
Sir, so we can it is possible for someone, so that's basically how ionization takes place.
हाँ.
Okay, sir.
ठीक है. Now अब notice करना, coming back to the experiment itself, तो आपको एक basic background समझ में आया है about what black body is. तो अब notice करना कि experiment में क्या हो रहा था. So in this experiment, ठीक है, इनफैक्ट जो टास्क दिया गया था, ठीक है, साइंटिस्ट को, इट वाज एक्चुअली इंडस्ट्री का प्रॉब्लम स्टेटमेंट. ठीक है, ये मेटल्स एट हाई टेम्परेचर आपको कहाँ पे दिखता है कॉमनली? अब तो खैर नहीं दिखता होगा बिकॉज वी हैव एडवांस्ड इनटू द फील्ड्स ऑफ एलईडी एंड एलसीडी। बट इसके पहले जब आप बल्ब्स, जो लाइट बल्ब्स होते थे, तो उसके अंदर कैसा होता था कि जो ये अंदर का फिलामेंट होता था, ठीक है, दैट वाज मेड अप ऑफ मेटल्स and alloys, and that was something which was at a high temperature, right? So what happened was that when this metal was heated to high temperature, it was emitting energy, and this energy had two parts to it. One was light and one was heat. तो उस टाइम पर जो साइंटिस्ट्स हैं, they were given this problem statement by the industry, that can we study these metals at high temperature? Can we study these black bodies and try to minimize the heat and maximize the light that are emitted? Because the primary purpose of the bulb is not to provide heat but to provide light. So can we study this black body and can we get this modification done? So with that perspective, black bodies were being studied with this particular example of metals at high temperature. तो यहाँ पे notice करना, in this experiment, radiations emitted by a bulb, ठीक है, जो फिलामेंट थे, ठीक है, मेटल फिलामेंट रहता है इसके अंदर, metal filament at high temperature, right? That is what was studied. And following observations were made. क्या ऑब्जर्वेशन था यहाँ पे नोटिस करना? So एक ऑब्जर्वेशन था related to the intensity of radiation. What is intensity? In layman's term, intensity is brightness. ठीक है, so यहाँ पे आप नोटिस करना, इनफैक्ट उल्टा ड्रॉ हो गया. So they were studying on the y-axis, ठीक है, different radiations emit हो रही थी. So इनका intensity was on y-axis and wavelength was on the x-axis. So यहाँ पर notice करना, what was the observation that was made, that low wavelength के radiations क्या हो गए? What are the low wavelength radiation? Gamma rays. ठीक है, इनकी इंटेंसिटी भी कम है. जो हाई वेवलेंथ के रेडिएशन हो गए, हाई वेवलेंथ के रेडिएशन क्या हो गए? से रेडियो वेव्स, माइक्रोवेव्स, लाइक इनकी भी इंटेंसिटी कम है. एंड समवेयर इन बिटवीन, लाइक इंफ्रारेड रीजन, विजिबल रीजन, यूवी रीजन, यहाँ पर इंटेंसिटी ज्यादा आ रही है. So this is the kind of observation that was made, that low wavelength is being emitted at a lower intensity, and higher wavelength is also being emitted at a lower intensity. Like around this visible region, UV region, is where the intensity of radiation is maximum. ठीक है. Now अगर हम लोग इसी में नोटिस करना, अगर हम लोग टेम्परेचर बढ़ा देते हैं, ठीक है, तो क्या ऑब्जर्वेशन आ रहा था यहाँ पे नोटिस करना. This was the first observation itself, how intensity versus wavelength का graph was. The second observation was that if we increase the temperature, right, ये एक से lower temperature पे plot हो रहा था, and हम लोग एक higher temperature पे अगर इसको plot करते हैं तो ये graph कुछ इस तरीके से आ जाता है. ठीक है, क्यों आ जाता है वो अभी आप एक बार के लिए होल्ड कर लो. लाइक हम लोग जस्ट पहले एक्सपेरिमेंटल ऑब्जर्वेशन ही देख रहे हैं. एंड ये जो पीक है, ठीक है, दिस शिफ्ट्स टुवर्ड्स अ लोअर वेवलेंथ. ठीक है, मान लो ये T1 टेम्परेचर पर था, ठीक है, ये ग्राफ T2 टेम्परेचर पर है, एंड T2 इज ग्रेटर देन T1. And what we see is that comes out as an observation is that if temperature increases, the peak shifts towards lower wavelength. Right? In fact, ये आप लोगों ने शायद अगर कभी ऐसे नोटिस करा हो, जैसे जब इंडस्ट्री में मेटल्स की फॉर्जिंग होती है, लाइक यू हैव दीज मेटल्स लाइक आयरन एंड ऑल, जिससे डिफरेंट शेप्स एंड साइज में मोल्ड किया जाता है, तो उसके पहले उनको हीट अप करा जाता है, राइट. एंड इसमें ऐसा रहता है दैट यू नो इफ यू हीट देम अप, increase their temperature, right, initially like they would be you know red in color. They would show like red wavelength की light को सबसे ज़्यादा वो emit करते हैं, उसकी intensity red की सबसे ज़्यादा रहती है. बट आप temperature और बढ़ाते हो तो फिर blue color दिखने लगता है, blue light की intensity ज़्यादा हो जाती है. So this was the experimental observation that was for the particular experiment that was being studied. हाँ, बोलो आरवी.
सर मैं डिस्कनेक्ट हो गया था, ये लास्ट पॉइंट फिर से एक्सप्लेन कर सकते हैं कि ये वाला बस.
हाँ, राइट. सो इस पे मैं बस आप लोगों को जस्ट एक्सपेरिमेंटल ऑब्जर्वेशंस बता रहा हूँ कि इस तरीके की ऑब्जर्वेशंस आ रही थी जब एक बल्ब से एमिटेड रेडिएशंस को स्टडी करा जा रहा था. ठीक है, रेडिएशंस दैट वर एमिटेड. अब बल्ब एट हाई टेम्परेचर मेटल फिलामेंट क्या हो रहा है, ब्लैक बॉडी की तरह बिहेव कर रहा है. तो ब्लैक बॉडी की तरह बिहेव कर रहा है तो डिफरेंट वेवलेंथ के रेडिएशंस एमिट हो रहे हैं, राइट. बट उसमें क्या ऑब्जर्वेशन आ रहा था, उसमें ये ऑब्जर्वेशन आ रहा था कि ऐसा नहीं है कि सबके सब वेवलेंथ सेम इंटेंसिटी से एमिट हो रहे हैं. ठीक है, इंटेंसिटी मतलब ब्राइटनेस.
हाँ सर.
सो सबके सब वेवलेंथ सेम इंटेंसिटी से नहीं आ रहे थे. इनफैक्ट गामा रेज वगैरह तो बहुत कम आ रहे थे, लाइक रेडियो वेव्स, माइक्रोवेव्स भी बहुत कम आ रहे थे. जो मेजर रेडिएशंस एमिट हो रहे थे वो समवेयर इन बिटवीन, लाइक विजिबल रीजन, यूवी रीजन, यू नो इंफ्रारेड रीजन, इसके अराउंड पे आ रहे थे. ठीक है, तो दैट वाज वन ऑब्जर्वेशन. एंड देन दे आल्सो फाउंड दिस कि अगर हम लोग टेम्परेचर चेंज करते हैं, ठीक है, अगर हम लोग टेम्परेचर चेंज करते हैं इस मेटल फिलामेंट का, राइट, तो पैटर्न सेम सा ही रहता है. लाइक ऐसा नहीं कि पैटर्न चेंज हो जाता है. लाइक लेसर वेवलेंथ के लेसर इंटेंसिटी, हायर वेवलेंथ के भी लेसर इंटेंसिटी, समवेयर इन द मिडिल यू हैव हायर इंटेंसिटी. तो पैटर्न वैसे ही रहता है. बट ये जो पीक था, जो ये
थोड़ा नीचे शिफ्ट हो जाता है,
दैट शिफ्ट्स टू अ लोअर वैल्यू ऑफ वेवलेंथ. ठीक है, जैसे फॉर एग्जांपल, दिस इज जस्ट एन एग्जांपल, मान लो ये पहले रेड के लिए था, ठीक है, मैक्सिमा आ रहा था, अब वो ब्लू के लिए आने लग गया.
ओके सर. नीचे शिफ्ट होता कब है,
जब टेम्परेचर इंक्रीज करते हैं.
ठीक है सर.
ठीक है, सो दिस वाज द ऑब्जर्वेशन दैट वाज मेड. अब नोटिस करना, नाउ रादर देन बीइंग एबल टू एक्सप्लेन दिस ऑब्जर्वेशन, ठीक है, इनफैक्ट ये पहली ऑब्जर्वेशन पर ही वेव थ्योरी ऑफ लाइट फेल हो गया। किस तरीके से आप यहाँ पे नोटिस करना that when wave theory of light was applied to this particular setup, it was not even able to explain the first observation. So notice karna, however, the wave theory of light was not able to explain these observations. In fact, what we see is that जो wave theory of light था, it gave drastically different results as compared to what was hoped for. तो यहाँ पर आप notice करना that in a very simple manner, ये वाला जो ग्राफ था, ठीक है, ये हमारा एक्सपेरिमेंटल ऑब्जर्वेशन था, राइट, एंड द वेव थ्योरी, ठीक है, यहाँ पे नोटिस करना, ये वेव थ्योरी ने वेव थ्योरी को ये इंटेंसिटी वर्सेस वेवलेंथ का प्रिडिक्शन करना था। तो व्हाट वेव थ्योरी प्रिडिक्टेड was that intensity is just inversely proportional to wavelength raised to the power of 4. कैसे वो उसके पीछे की मैथमेटिकल बैकग्राउंड है, बट दिस वाज द theoretical prediction, and according to this theoretical prediction, like the graph should be something of this nature, that हायर वेवलेंथ्स के लिए तो ऐसा हाइपरबोलिक नेचर रहेगा ग्राफ का, बट ये इसी तरीके से आप लैम्डा कम करते रहोगे तो इंटेंसिटी बढ़ती रहेगी, राइट, दिस इज व्हाट दिस मींस, आप लैम्डा कम करते रहोगे तो इंटेंसिटी बढ़ती रहेगी। तो ये थ्योरेटिकल प्रेडिक्शन आया, ठीक है। सो दिस वाज द, यू कैन से, the theoretical prediction. So this is something which was drastically different from experimental observation, and this is called as, in fact it is given a common name called as UV catastrophe, because it was a catastrophe in the sense that the theory was predicting such absurd results. Like according to the theory, matlab, for lower wavelengths, the intensity should be so high that everything around it should be just like exposed to so much high radiation कि वो सब तहस नहस हो जाएगा। Because as you can see, lambda मैं कम करता जा रहा हूँ, मतलब जो बल्ब है वो massive amount में lower wavelength, right, यानी कि गामा रेज जो कि harmful radiations होती है वो emit करना चाहिए था, but ऐसा हो नहीं रहा था। So this is, in fact, was called as a big, failure of wave theory of light to explain this problem associated with black body radiation. Now, हाँ, अब इससे ज़्यादा डिटेल में हम लोग जाएंगे नहीं यहाँ पर। हाँ, बोलो ईशान।
सर आप वापस समझा सकते हो कि वेव थियरी क्यों फेल हो गया था?
Like that is what I am trying to tell you, that wave theory का जो mathematical prediction आया था, ठीक है, ये आप फिजिक्स में पढ़ते हो क्लास 12th में, रेली-जीन्स लॉ कहते हैं इसको, that it predicted this kind of a behavior of the black body, that wavelength कम होता जाएगा तो intensity of radiation बढ़ता जाएगा। However, The experimental observations do not agree with that at all. And the difference was so like stark, it was so evident that it was a miserable failure of wave theory of light. अब ये चीज कैसे आती है, like how this prediction comes, ये आपके लिए अभी समझना थोड़ा ट्रिकी है, because this is again, as I said, the mathematical treatment of wave theory of light. ठीक है, तो अब इसके पहले like काफी अच्छे observations आ रहे थे wave theory of light से, like a lot of things we were able to understand and study, right? But as time passed by, as more of such discoveries happened, there were these loopholes that were coming in the wave theory. This was the first one, as you can see, black body radiation, where the theoretical predictions were way off from what the experimental observation, right? So यहाँ पर notice करना that what we can conclude from here is that theoretical predictions matched with experimental observations for larger wavelengths. So they matched with experimental observations for higher wavelength, like this region you can understand. But in this region, right, which is the lower wavelength, okay? So lower wavelength, इसमें it is here where we say that I should say around lower wavelength. Theory deviated drastically from experimental observations. Right, so this was something, let me use a different color ink so as to highlight this point. ये experimental था, ये theoretical था. ठीक है. Now अब इसके बाद में notice करना, हाँ मैं लेता हूँ एक एक करके आपके डाउट्स. एक मिनट रुक जाओ, just let me complete this point. That इसके बाद में what we say is that Max Planck, ठीक है, who worked on this black body radiation experiment, ठीक है, Max Planck, he provided an explanation. For this mismatch, and in order to do so, he included a fundamental assumption or modification in the wave theory. He included certain, ये हम लोग discuss करेंगे what this assumption was, because this is what is important for us. He introduced certain fundamental assumption or modification in the wave theory to match theoretical calculations with experimental data. This led to the development of quantum theory of light. So now let's understand what is it that Max Planck proposed in a point by point manner, and we'll come to this understanding of quantum theory of light. However, before proceeding there, आप लोगों के कुछ डाउट्स हैं, एक एक बार क्विकली उनको एड्रेस कर लेते हैं. हाँ, बोलो देखिए.
Yes, sir. So why is the intensity going higher for visible light and UV rays?
Right. So this is something which was, as I said, was something that we were studying for, say, metals heated at higher temperature. Now, it was an observation that was coming that when you heat up a metal, right, it starts emitting radiations. And neither we are seeing radio waves or microwaves coming out of it, neither we are seeing gamma rays or X-rays coming out of it. Well, we do see X-rays also, but in a very less intense manner. What we saw experimentally was that this UV region, visible region, this infrared region ke around, a lot of intensity, a lot of electromagnetic radiation is coming out. Now, this depends on object to object and the temperature at which it is present. Okay, so this observation that we came across, when objects are heated, they emit radiations, and the kind of radiations that they emit was found to be, heavily dependent on the temperature. So, जैसे अभी room temperature पे, like you have iron kept in front of you, it will not be, emitting such kind of radiations. Okay, in fact, at room temperature, like iron would be, just absorbing certain radiations, reflecting certain radiations, and जो भी उसमें atoms present होंगे जिनके electrons के excitation de-excitation से जो भी एक select wavelengths that can be emitted or absorbed. But उसी iron के piece को, if you are heating up to a high temperature, then what happens is that the atoms present inside that iron, right now, they have such kinetic energy, they have such energy associated with them that उसमें अब जब excitation de-excitation हो रहे हैं electrons के, then the radiations that are coming out are in the following manner, as you can see in this graph, and the intensity of radiations which are in the visible region, which are in the UV region, are coming out to be maximum. ठीक है? हाँ, बोलो.
Yes, sir, got it. So basically, it was only during the experimental observations it was found out, which was not earlier. It was not found out earlier.
So again, what we are saying is that first we are trying to understand this experimentally. Okay, that there are certain radiations that are being emitted. तो radiations की intensity and all कैसा है? So ये हम लोगों ने experimentally समझा. ठीक है? अब इसके पीछे का हम लोग background समझना चाह रहे थे. हम इसके पीछे का background क्या समझना चाह रहे थे कि ऐसा, like exactly the question that you are asking, कि ऐसा क्यों हो रहा है कि visible region के around maxima आ रहा है, UV के around maxima आ रहा है, why not other wavelengths? That is what we were trying to explore, because ये जो problem statement था, bulb वाला, कि भाई हमको bulb से ना visible light सबसे ज़्यादा चाहिए, क्योंकि वही हमारा काम है बल्ब का. हमको ऐसा बल्ब नहीं चाहिए जो यूवी लाइट थ्रो कर रहा हो या एक्सरे थ्रो कर रहा हो, उससे तो हमारा नुकसान हो जाएगा. सो दैट इज व्हाट इज बीइंग एक्सप्लोर्ड एंड सर्टेन सच ऑब्जर्वेशंस वर कमिंग. तो मैंने आपको ये ऑब्जर्वेशंस बताई कि ऐसी ऑब्जर्वेशंस आ रही थी, राइट. एंड इफ यू इंक्रीज द टेम्परेचर एंड द लाइक इंटेंसिटी का प्रोफाइल, इट शिफ्टेड टुवर्ड्स अ लिटिल लेफ्ट. जब वेव थ्योरी इसको पढ़ने जा रही थी, इसको समझने जा रही थी, राइट, क्योंकि थ्योरी क्या करती है, थ्योरी ट्राइज टू एक्सप्लोर थिंग्स ग्राउंड्स अप, कि भाई, what is the background behind this observation? What is happening? However, in doing so, the theory failed miserably. Like it was not even able to predict the kind of observations that were coming, for a large range of lower wavelengths. The theory was saying कि भाई अगर wavelength कम है तो intensity बहुत ज़्यादा होनी चाहिए, यानी कि जो UV rays, X rays रहेंगी, gamma rays रहेंगी, like उनका तो इतना high intensity होना चाहिए कि सब कुछ like आसपास तबाह हो जाना चाहिए. So this was a catastrophic failure of wave theory of light.
Yes, sir. Thank you.
हाँ. बोलो Shravin.
Yes, sir. Sir, but we cannot say na कि the wave theory is completely a failure, because how will they then explain the observations of Thomas experiment, Young's experiment?
Right. So आप वही समझो यहाँ पर ध्यान से, that the way in which we are progressing is we are trying to understand chronologically how things happen. See, whenever science evolves, older theories are the ones which are considered to be correct at that point
Yes,
in
sir.
time, right? Because they did explain a lot of observations that we come across, right?
Yes, sir.
But then there are some observations which they are not able to explain, right? Then someone modifies those theories and evolution happens, and then we get a better theory that is a more robust version which can explain more observations around us.
Yes, sir.
That is the way in which we are progressing.
Also, sir, all the things which are around us have some radiation, means they are emitting some radiation from itself, right? Means even the table which I am watching this lecture is also emitting a small amount of radiation, right?
Right. Absolutely right.
Okay, sir.
So can you hear me?
हाँ, बोलो.
Yes, sir. So what exactly is intensity of light? Like, how is,
Intensity
radiation, how is it quantified?
हाँ, intensity का एक technical definition रहता है. Intensity का technical definition होता है energy per unit area per unit time. Okay, this is the technical definition of intensity. Energy per unit area per unit time. Now,
And this is different from brightness, right?
No. This is what is called as brightness in layman's term. Like when we say.
So, but then there's a different SI unit for that altogether, right? A fundamental unit for that. Then how come if we can express it in terms of units we already have?
Okay, no. Absolutely right. From the units and dimensions perspective, you are right. But when I'm talking about, how to explain intensity, like, so there is a source, right? And it is emitting certain radiations, right? So that source can be, emitting radiations with a lower intensity. It can be emitting with a higher intensity, right? Rather than talking about the technical definition of it, that it is energy per unit area per unit time, right? We simply represent it saying that intensity and brightness are proportional to each other. They are not exactly the same. We are saying that more the intensity, more will be the brightness, lesser the intensity, lesser will be the brightness.
Okay, sir. So, and if it's related to energy, then how come the lower wavelengths like gamma radiation or so I guess it's the amount of waves, right, that is dominating here, not the energy of the individual waves, right?
True. So that is what comes from the quantum theory of light.
So just that the amount of visible light is more than gamma, but so that's why this energy thing doesn't come into play.
हाँ. So अभी जब हम quantum theory पढ़ लेंगे ना, तो उसके बाद में I will break down this energy into two parts. The number of photons and the energy of each photon.
And the number is dominating here.
Right. वो भी हम करेंगे जब हम लोग क्वांटम थ्योरी का डिस्कशन करेंगे. हाँ, आएंगे, बट वहां पे रुक जाओ, अभी क्वांटम थ्योरी पे आए नहीं. हाँ, बोलो आपने.
Yeah, so in the second graph,
हाँ.
the temperature. So if we are increasing the temperature, the point at which the intensity is highest, the wavelength is coming below, like no wavelength, right? So why is this exactly happening?
That is what we are saying. No? That is what the scientists at that point in time were trying to explore. But the theory that we were using to explore it failed miserably.
Okay. So, but it was true for higher wavelengths, right? According to the wave theory.
For a higher set of wavelengths, it was matching quite well, but lower wavelengths के लिए it became a problem.
Okay, sir. Thank you.
हाँ, बोलो देवांशी.
Oh, so I think I forgot to lower my hand last time.
अच्छा अच्छा. हाँ, बोलो गौरव.
Sir, I had a question. Is there any like is the momentum of photons being involved over here, or is it just the number?
अभी नहीं. Not discussing quantum theory before we discuss it with everyone.
Sir, so there is only the number which is mattering, right?
All right. ठीक है, अब थोड़ी देर होल्ड करो अपने डाउट्स को. लेट मी प्रोसीड अहेड विद द क्वांटम थ्योरी ऑफ लाइट, अदरवाइज डाउट्स में हमारा टाइम चला जाएगा. सो यहाँ पर अब ऑब्जर्व करना, व्हाट इज इट दैट मैक्स प्लैंक डिड टू प्रेजेंट हिज explanation for black body radiation. So according to Max Planck, he presented that matter emits or absorbs radiation in discrete units. Not in a continuous manner. Right, so what it is trying to say is that, say if you have an object, right, that is emitting radiations. Now it is emitting these radiations in a discontinuous manner, rather than the earlier assumption with the wave theory of light that is a continuous manner. तो ये ऐसे नहीं कर रहा है. Like this is a simplified explanation, simplified representation, I would say, for how objects are emitting or absorbing radiations. So Max Planck proposed कि ऐसा नहीं है that जब इलेक्ट्रोमैग्नेटिक रेडिएशंस एक ऑब्जेक्ट एमिट कर रहा है तो वो मतलब हमें ऐसा लगेगा, राइट, फॉर एग्जांपल बिकॉज फ्रॉम अ ह्यूमन आई पर्सपेक्टिव, फ्रॉम अ you know our ability to observe thing around us, we might see that it is continuous, right? For example, when you see an object, a solid object in front of you, you may say कि ये तो solid है, right? इसके अंदर like everything is densely packed and there is no empty space inside. But only when we develop the capability of observing things in detail, we realize that matter is made up of object and matter is made up of atoms, and atoms are vastly empty from inside. So उसी तरीके से what Max Planck proposed is that आपको लग रहा है, let's say you have a bulb in front of you which is emitting light, so you may perceive that the light is coming continuously to you, but the way in which the light or the electromagnetic radiation is coming to you is not continuous. It is in fact coming in form of discrete units. Now यहाँ पर how to understand this discrete unit, like what do we mean by this discrete unit, comes the second point. Observe karna. So he says you can think of this discrete unit from the perspective of energy. So how to go about talking about this discrete unit? The energy emitted in form of electromagnetic waves or electromagnetic radiation is quantized. That is not continuous. what it means is, यहाँ पर notice करना, this means the total energy present in a beam of electromagnetic radiation is a collection of small or you can say discrete units or packets of energy called as photons or quanta. Mathematically, like what Max Planck is saying is that when you have a source emitting certain light, certain radiation, right? We say that that light or radiation is energy being transferred from one region to another. And what Max Planck proposed is that that energy which we are seeing is being emitted in form of these electromagnetic radiation is not something which is continuous, but it is quantized in form of these photons, right? So the energy of light is made up of these photons, right? So N would be a natural number like 1, 2, 3, and so on and so forth, which represents the number of photons present in the beam. And E photon would represent the smallest unit of energy of energy present in the electromagnetic radiation that we are discussing. So this is something which was the first theory that talked about the quantized nature of light. अभी खत्म नहीं हुआ, अभी इसके अंदर और पॉइंट्स हैं. Like this is something similar to, as I said, charge का quantization. Like if you remember, like इसके पहले भी हम लोगों ने ये quantization का concept पढ़ा था जब हम लोग Millikan's oil drop experiment के बारे में discuss कर रहे थे, where we understood that charge, right? We have come across this property around us called charge, right? And we came across this observation that charge around us can be positive or negative. Like charges, positive repel each other, opposite charges attract each other. ये अब हमारे around observation थी, right? And then when we studied about that charge, we found out that that charge is also quantized. It is not something which is a continuous quantity. Like charge exists as a sum of discrete units, and the smallest of that charge was the charge of an electron. उसी तरीके से यहाँ पर Max Planck proposed that light around us, electromagnetic radiation around us, right, is made up of small units. And how to understand that small units? He used the perspective of energy. That light or electromagnetic radiation around us is energy being transmitted from one region to another region. And then you can understand that this energy that is present in an electromagnetic beam or an electromagnetic radiation is not continuous. It is in fact made up of these small discrete units of energy called as photons. Now इसी में he went on to further elaborate. यहाँ पर notice करना, he went on to further elaborate on this aspect as dual behavior. So यहाँ पर notice करना, will come across this statement that according to Planck, this photon represents particle nature of light. In addition, to the wave nature that we had seen and explored before. So what he meant to say, what Planck concluded is that thus light has dual behavior. That is, light or electromagnetic radiation can behave as particles, or light can, I should say, let me be more technically correct, light can show particle nature as well as wave nature. This is the most technically correct statement when we talk about this dual behavior of light. Okay, incorrect statements observe kar lena. Like sometimes you come across incorrect statements also. Is light a particle? The answer is no. Is light a wave? The answer is no. Is light both particle and wave? What is the answer? The answer is no. Okay, that is where I want you to be extremely cautious about this. The technically correct statement is that light can show particle nature as well as wave nature. This is what the correct statement is. You should not go for this statement that is light particle, is light wave, is light both. No, ये तीनों incorrect statements हैं. Okay, light can show particle-like behavior as well as wave-like behavior. We have studied light, and in some experiments, for example, Young's double slit experiment, we found out that light exhibited wave nature. We are going to come across certain experiments in which light shows particle-like behavior. Like जो ऊपर 4 experiments मैंने आपको दिखाए थे, black body radiation, photoelectric effect, इसमें light, ये जो experiments हैं, ये ऐसे explain हो पाएंगे अगर हम light का particle nature मानेंगे तो wave nature से ये explain नहीं हो पाएंगे. So what we are seeing is light can show both particle nature as well as wave nature. It is neither particle nor wave nor both. ठीक है, तीनों incorrect है. This is what the technically correct statement is. And to be honest, we have not come across an experiment in which both can be seen simultaneously. Okay, we have not seen an experiment in which both these nature are to be viewed or are to be observed simultaneously. In some scenarios, we come across that particle nature of light is doing the explanation. In some scenarios, we come across that the wave nature of light is doing the explanation. And that is why it is important to understand this statement from a very, very stringent technical point of view. ठीक है? हाँ, अब ऐसा नहीं है कि हम लोग मतलब लाइट को कुछ लाइक नया नाम दे देंगे कि इट इज पार्टिकल एंड वेव का कॉम्बिनेशन, सो लाइक पार्टी वेव या वेवटिकल, ऐसा कुछ नहीं नाम देते हैं इसको. वी जस्ट सिंपली लीव इट एट दिस स्टेटमेंट दैट लाइट कैन शो पार्टिकल नेचर एज वेल एज वेव नेचर. ठीक है. नेक्स्ट इंपॉर्टेंट पॉइंट समझना, अभी थियोरी थोड़ा सा और प्लैंक का इंपॉर्टेंट बाकी है, यहाँ पे नोटिस करना. प्लैंक also established an important relationship between this particle nature and wave nature. Really, really important relationship. Between particle nature and wave nature. Right? कैसे establish किया, यहाँ पे notice करना. The energy of photon is directly proportional to the frequency of electromagnetic radiation. Right? This left hand side, it represented the particle nature. Right, that energy of light is quantized, and this frequency part, this on the right hand side, represents the wave nature. So this is where Planck established this important relationship between the particle nature and the wave nature. Energy of photon is directly proportional to the frequency, and the proportionality constant was also provided by him, which we call as Planck's constant. So he's presented this relationship, this result, that energy of photon is equal to h nu, right, where h is this proportionality constant called as Planck's constant. इसका वैल्यू आपको ध्यान में रखना है. This is something to be remembered for future. 6.626 into 10 raised to the power of minus 34 joules second. ठीक है. So this was a quick key summary of the quantum theory of light. हाँ, अब इसमें एक एक करके आपके डाउट्स ले लेते हैं. So we'll start with first Tausif. हाँ, बोलो Tausif.
Yes, sir. Sir, so what is the meaning of the word quantum?
हाँ, so quantum in literal sense means smallest unit. So when we see a quantity, okay, when we observe a quantity, it could be quantity of charge, it could be quantity of mass, right, it could be quantity of energy, right. So whenever we come across this quantity of like property, what we say is that if that quantity exists as a multiple of smallest units, then we say that quantity is quantized. So for example, जैसे आपने चार्ज के बारे में पढ़ा था, right? In earlier observations, like what we came across, जब चार्ज का डिस्कवरी हुआ, like for example, you had a glass rod, right, and a silk का cloth, right, and you rub them together, and what you get is a static charge that gets developed, right? And what we see is that like charges repel each other, opposite charges attract each other. तो basically charge करके एक फंडामेंटल प्रॉपर्टी डिस्कवर हुई, ठीक है? This is a observation that we have around us in the universe. We come across this property called as charge. Now अब इस चार्ज की प्रॉपर्टी को जब हम लोग स्टडी करते हैं तो हम लोगों ने ये भी नोटिस किया कि समटाइम्स वी हैव a greater value of charge, sometimes we have a lesser value of charge. So there is a magnitude, there is a quantity associated with this charge. And then we further studied about charge, and हमें समझ में आया that when we talk about the quantity of the charge, we found it to be made up of small individual units of charge which cannot be further broken down, and this smallest unit is called as the quanta of charge, okay, which we today known as the charge of electron, and its value is 1.6 into 10 to the power of minus 19 coulomb. तो उसी तरीके से मैक्स प्लैंक ने सजेस्ट किया कि जब हम लोग इलेक्ट्रोमैग्नेटिक रेडिएशन के बारे में बात करते हैं, इलेक्ट्रोमैग्नेटिक रेडिएशन क्या है? Electromagnetic radiation is, in very simpler terms, like it is energy being transmitted from one region to another region, right? जैसे आपने वो वीडियो देखा था, right? उस वीडियो में कैसा था, आपने नोटिस किया होगा कि उसमें एनालॉजी दी थी वाटर के रिपल्स एज वेल एज इलेक्ट्रोमैग्नेटिक रेडिएशंस के बारे में, that both are transferring energy from one region to another region, right? However, electromagnetic radiations do not require any medium, whereas that water wave required water as a medium, right? So yahan par bhi what we are seeing is that this electromagnetic radiation is basically energy transmitted from one region to another region, and this energy is something which Max Planck said is not continuous. It is something which is quantized, like it is made up of these smallest units of energy called as photons, ठीक है? All right, next देखते हैं. हाँ, देवांशी, आपका क्या डाउट था?
Sir, we are studying all these theories to go back to Bohr's atomic model, right?
So Bohr's atomic model will incorporate, जैसे मैंने आपको बताया था ना, that Bohr's atomic model जो है उसका validation कहाँ से आया था? Atomic spectrum से, ठीक है? I don't know if you know about atomic spectrum or not, but ऐसा नहीं था ना कि बोर ने बोल दिया कि ऐसा होता है तो हम लोग मान लिया. Like there was a strong experimental evidence which was supporting Bohr's model, which was this atomic spectrum experiment. Now ये atomic spectrum experiment समझ में ही आता है जब हम लोग quantum theory of light पढ़ते हैं, ठीक है? That is why I take this before Bohr's model. Booklet में in fact Bohr's model पहले दिया हुआ है, बाद में फिर photo electric effect and atomic spectrum के बारे में बात किया जा रहा है, but I will take them beforehand. ठीक है? हाँ, बोलो गौरव.
Sir, I had a few questions. Sir, when we say that light can behave either like a particle, light can have either particle nature or wave nature. So in particle nature, can we say that the photons have some mass?
So okay, photons का we say that there is no rest mass, ठीक है? But
as in when they are at rest.
हाँ, but when they are associated with energy, there is a mass energy equivalence that is used to talk about the mass of photons also.
Okay, sir, and next, when we say that it is quantized, like the energy is quantized in this case, sir, so the energy of a photon, the smallest unit for the energy of a photon, it depends on each electromagnetic radiation, right? Because like as we know that it is proportional to the frequency, right? So it changes with every radiation.
हाँ, so मतलब जैसे ये जो यहाँ पर मैंने ऊपर रिलेशनशिप लिखा था, ठीक है, एनर्जी ऑफ लाइट इज n टाइम्स एनर्जी ऑफ फोटोन, तो इसमें मैंने ये अजम्पशन लिया है दैट द लाइट, द बीम ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन जिसके बारे में हम बात कर रहे हैं वो किसी एक वेवलेंथ का ही है.
ओके सर.
ठीक है, तो मैंने यहाँ पर ये अजम्पशन लिया एंड इस अजम्पशन को हम लोग एक सिंगल वर्ड से भी डिनोट करते हैं, मैंने बीम ऑफ मोनोक्रोमैटिक. ठीक है, ये वर्ड यूज किया जाता है. व्हाट डज इट मीन? मोनोक्रोमैटिक का मतलब होता है
ओनली
कि
वन
एक ही
लाइट,
वेवलेंथ
वन
से बना हुआ है.
frequency. Sir, last question, sir. When we say that charge is also quantized, but there are particles like quarks and bosons, we say that they have a fractional charge.
हाँ हाँ, वो ठीक है, मतलब दैट इज ट्रू. क्वार्क्स की कैटेगरी में जब हम लोग जाते हैं तब हम लाइक और चीजें समझ पाते हैं. बट अभी राइट नाउ अपने सिलेबस के पर्सपेक्टिव से हम लोग लाइक स्मॉलेस्ट यूनिट ऑफ चार्ज को इलेक्ट्रॉन ऑफ चार्ज, चार्ज ऑफ इलेक्ट्रॉन ही ट्रीट करेंगे.
ओके सर, थैंक यू.
राइट, उसमें 1/3 2/3 रहता है, बट आगे की थ्योरी होगी. बोलो हेजल. एक मिनट, लेट मी अनम्यूट यू.
So on what basis did the Max Planck he derived that light is in the form of discrete units and not is not continuous?
Right, that was the interesting part. So he did manipulation. He did mathematical manipulation. Right. In fact, let me see if I can find those exact words from Max Planck biography. Like he himself was a skeptic of it, whether what he has done is correct or not. What he did was he mathematically, tried to force fit the data. जो भी एक्सपेरिमेंटल ऑब्जर्वेशन आ रहा था एंड उसको थियरी से कैसे एक्सप्लेन करें उसके लिए ही डिड बैक कैलकुलेशन एंड केम अप विद दिस assumption. However, ढूंढना पड़ेगा मुझे, मैंने पहले कहीं पे देखा था वो. ठीक है, बट देयर वाज नो लाइक fundamental basis to it, right? He did a mathematical manipulation and his manipulation worked, and then he said that how we can understand that manipulation. So he figured out, he said that that manipulation, it makes sense if we think of energy as discrete units rather than a continuous quantity.
So another question was that if light, which is made up of photons, shows both particle nature as well as wave nature, then all the other rays such as gamma rays and they also show particle nature as well as a wave nature, or are they different?
So हाँ, मतलब हम लोग थोड़े टाइम में आएंगे एक और थ्योरी पर which comes some 20 years later, post quantum theory of light, which is dual nature of matter. So even atoms, molecules, alpha particles, these also possess dual nature. Like they also possess particle nature as well as wave nature. So we are going to come across that theory. ठीक है, हाँ बोलो श्रेय.
Sir?
हाँ.
my doubt was that if the intensity of light waves of very less wavelength is less, then how can intensity be inversely proportional to lambda raised to 4?
So this is what then was concluded later ना, ये तो वेव थ्योरी ऑफ लाइट ने बता दिया, राइट? बाद में फिर जब क्वांटम थ्योरी आया तो क्वांटम थ्योरी ने बोला that when we talk about the like intensity which is proportional to the energy, then that energy, ठीक है, यहाँ पे अब आप notice करो, when I combine these two equations, this is equation 1 and this is equation 2, ठीक है, I can write here h nu or hc by lambda, right? So इन दोनों इक्वेशंस को मैं कंबाइन कर रहा हूं तो क्या दिख रहा है, दैट एनर्जी ऑफ लाइट इज इक्वल टू n टाइम्स hc by lambda, राइट? सो ये एनर्जी यहां पर जो है, दिस इज n टाइम्स नंबर ऑफ फोटॉन्स इनटू एनर्जी ऑफ ईच फोटॉन, राइट? सो व्हाट एक्सप्लेन्ड दिस ऑब्जर्वेशन वाज नॉट जस्ट द लैम्डा बिट बट आल्सो द नंबर ऑफ फोटॉन्स. सो यहां पर जो लोअर वेवलेंथ है, ठीक है, लोअर वेवलेंथ के फोटोन की एनर्जी ज्यादा होगी, लाइक ये पार्ट ज्यादा होगा, ठीक है, बट अब उसके नंबर ऑफ फोटॉन्स ही अगर कम एमिट हो रहे हैं तो उसकी इंटेंसिटी कम रहेगी, ठीक है. सो दिस एक्सप्लेनेशन केम लेटर विद द हेल्प ऑफ क्वांटम थ्योरी ऑफ लाइट, नॉट समथिंग व्हिच वाज देयर इन द वेव थ्योरी ऑफ लाइट, बिकॉज वेव थ्योरी में लाइक जो इंटेंसिटी एंड एनर्जी का रिलेशनशिप था वो इसी तरीके से था कि एक कंटिन्यूअस फॉर्म में है, अगर कम वेवलेंथ है तो ज्यादा एनर्जी है, ज्यादा वेवलेंथ है तो कम एनर्जी है. इट डिड नॉट टेक इनटू दिस assumption of that energy is made up of these individual units that are photons, ठीक है, समझ में आया श्रेय? All right. बोलो शरण.
Yes, sir. So, this quantum theory of light says that light sometimes behave as particle and sometimes as wave, right? So, what determines that the light will behave? Means this time light will behave like a particle, and in that case, light will behave as a wave. What determines that?
नहीं, that is not the way in which we are predicting कि कब light कैसे behave करेगा. We are seeing that light is showing certain phenomena, right?
Yes, sir.
And how that phenomena is being explained, तो उसमें sometimes the particle nature of light helps, sometimes the wave nature of light helps.
Yes, sir.
That is the way in which we are understanding this dual nature.
Okay, sir. And sir, I have another doubt that I have also read another statement about this quantum theory of light, that light is neither particle nor wave. So is it is also false, right?
Yeah, मतलब that is also a false statement.
Okay, sir. Got it.
So, sir, light is traveling in a wave nature, sir, but the smallest unit of light is photon in which it is traveling, sir. So it is showing both the particle nature and the wave nature. Sir, so it can be proved that light is traveling. Light can be both as a particle and wave. Light can show both.
ऐसे नहीं सोचते, मतलब when you are demonstrating one of these natures, like you have to be experimentally conclude कि this observation is being explained by this kind of nature. ऐसा नहीं है ना, मतलब ट्रैवल कर रहा है तो पार्टिकल भी ट्रैवल करता है और वेव भी ट्रैवल करता है, तो उससे क्या जज कर लिया आपने?
Okay, sir. Sir, and one more, sir. So Isaac Newton was also not wrong now in his observation that.
See, when we evolve over these theories, what we say is that they were incomplete theories. Like even जब हम बोर्स मॉडल से क्वांटम मैकेनिकल मॉडल पे भी जाएंगे बाद में, तो हम लोग ये नहीं बोलेंगे कि बोर्स मॉडल इनकरेक्ट है. What we will simply say is that the Bohr's model was incomplete. And with more knowledge, we are able to then understand better models.
Yes, sir.
Sir, can you scroll up
हाँ.
more? Sir, yes. So here you have written that matter emits or absorbs radiation in discrete units. Sir, so it is necessary that each discrete unit means is the same type of electromagnetic wave.
नहीं,
Like
बिल्कुल नहीं ना. जैसे ब्लैक बॉडी है तो अब वो डिफरेंट रेडिएशंस लाइक यूवी रेडिएशन भी एमिट कर रहा है और विजिबल रेडिएशन भी एमिट कर रहा है. ठीक है. बट अब जो यूवी रेडिएशन का फोटोन होगा वो अलग होगा फ्रॉम विजिबल रेडिएशन का फोटोन से.
सर तो नंबर ऑफ फोटॉन्स चेंज रहेगा ना, मतलब
हाँ, नंबर ऑफ फोटॉन्स भी अलग अलग रहेंगे और इंडिविजुअल फोटोन का एनर्जी भी अलग अलग रहेगा.
पर जो फाइनल चार्ज रहेगा वो सेम रहेगा.
फाइनल क्या चीज?
मतलब फाइनल एनर्जी जो रहेगा वो सेम रहेगा हर एक.
उन सब का सम रहेगा ना, राइट. अगर आपके पास में 100 फोटॉन्स यूवी के हैं, राइट, तो 100 into फ्रीक्वेंसी ऑफ द यूवी रेडिएशन लाइक एच न्यू, ये यूवी का फोटोन हो गया. और आपके पास 200 फोटोन से विजिबल रीजन के थे, राइट.
सर तो जो एनर्जी ऑफ इंडिविजुअल डिस्क्रीट यूनिट्स इक्वल रहेंगे कि
नहीं, अलग अलग रहेंगे ना. ये एच न्यू लाइक एच तो दोनों के लिए सेम रहेगा बट फ्रीक्वेंसी अलग अलग है ना यूवी और विजिबल की.
Okay, sir. So, but here it's also written that the energy emitted in the form of electromagnetic radiation is quantized.
हाँ.
सर तो उसका मतलब each individual unit का equal रहेगा कि सबका मिला के?
अगर हम लोग यहाँ पर ऐसे रेडिएशन की बात कर रहे हैं जो कि मोनोक्रोमैटिक है, ठीक है. मोनोक्रोमैटिक मतलब इसके अंदर एक ही टाइप का वेवलेंथ है या एक ही टाइप का फ्रीक्वेंसी है, तो सारे के सारे फोटॉन्स आइडेंटिकल होंगे और सबकी एनर्जी एच न्यू या फिर जो भी एच सी बाय लैम्डा उसकी फ्रीक्वेंसी या वेवलेंथ होगी उसके करस्पॉन्डिंग होगी. एंड इन सबको आप ऐड कर दो, राइट, तो इट विल बी सेम एज मल्टीप्लाइंग n इनटू नंबर ऑफ फोटॉन्स.
Yes, sir.
राइट. बट अगर ये मोनोक्रोमैटिक नहीं है, इसके अंदर डिफरेंट फोटॉन्स हैं, राइट, तो फिर आपका एनर्जी ऑफ लाइट क्या हो जाएगा? समेशन पता है कि नहीं पता है?
हाँ सर पता है.
तो नंबर ऑफ फोटॉन्स इनटू एनर्जी ऑफ ईच टाइप ऑफ फोटॉन, ऐसे आप आंसर कर दोगे.
Yes, sir.
ठीक है. ऑल राइट. देन बोलो अदिति.
यस सर मुझे ब्लैक बॉडीज में एक डाउट है, पूछूं?
बोलो.
So how do we know that the sun is absorbing radiation?
So okay, when we मैं आपको ये बताऊंगा जब हम लोग इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम के बारे में बात करेंगे ना.
Okay.
तब हम लोग एक ऑब्जेक्ट का एमिशन स्पेक्ट्रम और अब्जॉर्प्शन स्पेक्ट्रम दोनों के बारे में बात करेंगे.
Okay, sir.
वहाँ पे I'll take up this doubt.
And sir, also you derived a formula. Could you explain that?
Which formula?
I think वो नीचे है थोड़ा सा, like intensity का शायद.
Intensity का formula?
हाँ, this one शायद.
नहीं, ये तो definition है इसकी. मतलब ये formula, this formula comes from the definition itself that how intensity is technically defined. It is energy per unit area per unit time. So let's say you have a bulb which is throwing away light. So energy is being thrown, right? It is being thrown in all directions.
Yes.
Right? तो अब like in a given amount of time, like कितने एक क्रॉस सेक्शनल एरिया पे कितने फोटॉन स्ट्राइक कर रहे होंगे, कितनी एनर्जी आ रही होगी, उससे इंटेंसिटी कैलकुलेट करा जाता है. So that is the meaning of intensity.
So I think it was the formula regarding the photons, energy of photons upon and.
हाँ, नहीं क्या कह रहे हो?
I think it's the formula जो नीचे है ना, like energy photons related वाला. हाँ, this one sir.
नहीं, इसका derivation नहीं है. This is what Max Planck said, that this is what the relationship would be to the energy of photon. This is like a fundamental formula. इसके पीछे का derivation नहीं है. This is what he proposed. And then what we found this was to be the truth by all the observations that we came across.
Okay, and so when we say that light behaves as a wave in particle, it has a dual nature. We cannot say it's both, right? So it is basically made up of only photons, right?
See, when we try to understand the particle nature of light, then we say that yes, it is like photons.
Okay, but we cannot say that it's a particle or wave, right?
हाँ.
Okay, thank you, sir.
ठीक है. हाँ. बोलो next, Nihal.
So in the last point, if light, there's no experiment that concludes that it's a wave nature simultaneously, then how do you come up with the last point, like the relationship between both?
No, we didn't come up. That is what Max Planck proposed, that this is what should be the relationship. He did not derive it. He said that दोनों nature दिख रहे हैं आपको. This is what his genius was, na? This is what he awarded the Nobel Prize for. That he said that these are related in this manner and इनके relationship का constant भी मैं बता रहा हूँ. ये constant मेरे नाम पे रखो, Planck's constant. और चाहिए तो दुनिया की जितनी ताकत लगानी इसको टेस्ट कर लो, ये करेक्ट आएगा. ठीक है. हाँ, बोलो आरवीर.
सर तो उसने मतलब जैसे पहले मतलब उसने बैक कैलकुलेशन किया था, तो जैसे सर हम लोग को कोई क्वेश्चन नहीं आता तो हम लोग आंसर डाल के क्वेश्चन निकालते, वैसे ही किया था.
हाँ, in a very crude sense, yes.
अच्छा, तो सर मतलब फिर उसको assumptions के लिए नोबेल प्राइज मिला था?
नहीं, assumptions के लिए नहीं, उस assumptions के explanation के लिए.
अच्छा.
He proposed that what that assumption means also.
Okay, sir.
हाँ, बोलो मिहिर.
हाँ सर अगर वो लाइट पार्टिकल नेचर और वेव नेचर दोनों दिखा रहा है तो दोनों साथ में एग्जिस्ट तो करने चाहिए ना सर.
नहीं, वही चीज तो मैं आपको समझाने की कोशिश कर रहा हूँ. That is what the technically correct statement is. That light is neither particle nor wave. It is not both. जब हम लाइट को समझने की कोशिश करते हैं, उसको ऑब्जर्व करने की कोशिश करते हैं, तो सम एक्सपेरिमेंट्स में इसकी वेव नेचर सामने आती है, सम एक्सपेरिमेंट्स में इसकी पार्टिकल नेचर सामने आती है.
तो फाइनली वो फोटोन की तरह भी ट्रैवल कर सकता है और वेव की तरह.
हाँ, ऐसा हमें ऑब्जर्वेशन नहीं है कि कहाँ पर दोनों के दोनों नेचर एक साथ एग्जिबिट हो रहे हैं.
ओके.
बोलो देवांशी.
Yes, sir. So can we say that light is made up of the discrete units called photons and it travels in the form of waves?
मतलब like you are trying to force fit the dual behavior का definition?
No, not force fit. Like if we combine the dual nature, then we can say that light is made up of the units called photons, and when we
travel तो
understand,
फोटोन भी कर सकता है ना, ट्रैवल पार्टिकल भी कर सकता है, ट्रैवल वेव भी कर सकता है.
so till now it hasn't been actually proven.
हाँ, that is what I'm trying to say, that जैसे हम लोगों ने यंग्स डबल स्लिट एक्सपेरिमेंट देखा था, right? Now यंग्स डबल स्लिट एक्सपेरिमेंट में जो प्रॉपर्टी लाइट ने दिखाई,
wave nature,
that is an exclusive property of waves, कि waves ही इंटरफेरेंस या डिफ्रैक्शन शो करती है, right? पार्टिकल्स जब आपस में मीट अप करते हैं तो वो कोलाइड करते हैं. They don't show this kind of a behavior that waves show, right?
yeah.
वहां पर लाइट ने क्या करा? It didn't show particle behavior, it
only wave, yeah.
wave like behavior. ठीक है. Then अभी हम आपके साथ में अभी आगे भी डिस्कस करेंगे. Let's say फोटो इलेक्ट्रिक इफेक्ट का एक्सपेरिमेंट होगा, राइट? तो उसमें लाइक आई विल से कि जो वेव नेचर है वो एक्सप्लेन ही नहीं कर रही है ऑब्जर्वेशन. It is only particle nature that is explaining the observation. So what we are seeing is that light का explanation is a tricky job. And उसके explanation में कई बार wave nature यूज करना पड़ता है, कई बार particle nature यूज करना.
और कभी ऐसा नहीं हुआ कि दोनों साथ में आए?
नहीं.
Okay. And sir, according to the wave theory, the intensity is inversely proportional to the fourth power of wavelength, which was later proven to be wrong.
Yeah.
But then, sir, the intensity of scattering of light is inversely proportional to the fourth power wavelength.
हाँ हाँ, मतलब वो भी आप देखोगे, लाइक इसके पीछे का अगेन ये जो रिले जेन्स लॉ है, लाइक वहीं से ये सब आता है. बट अगेन आई डिड नॉट गेट इनटू द वेव थ्योरी ऑफ लाइट बिकॉज हमको वेव थ्योरी ऑफ लाइट पढ़ना ही नहीं है. हमको जो पढ़ना है वो अब क्वांटम थ्योरी ऑफ लाइट पढ़ना है, जिसके ऊपर मैं आपको आगे न्यूमेरिकल्स एंड ऑल कराना चाहूंगा.
Okay, sir.
Didn't go much into the wave theory.
Okay, sir. Thank you.
Sir, I had just had one question. Like, when we say that the waves, okay, let's say like in the case of photons, they're traveling like in photons. So at that time they have a momentum and they don't have a rest mass. Sir, so when they're traveling as in a kind of in a wave form, then they are using and they are transmitting energy in the form of waves, right?
Particles भी तो energy transfer कर सकते हैं ना?
No, sir. I'm saying if we don't take the case of particles right now, like I understood the part where particles are transferring the energy. I'm saying when the waves are traveling, they travel, they travel, and then they are transferring the energy in form of waves, right?
Right.
So, and sir, also that in the video which we saw, they were telling us that there are many electromagnetic waves around us right now. Sir, so is it possible that if they're traveling in form of particles, then the particles collide, and then there can be some
हाँ हो सकता है ना, जैसे
Sir, so then there will be interference. Sir, then let's say my laptop is connected to the internet. Sir, so then there are some waves between them, but then somebody is using my mobile phone in between, and there's possible chance of interruption of the internet.
Right. There is a possible chance depending upon the sensitivity. जैसे for example घर पे बैठे बैठे we don't give any we don't bother about it. But let's say जब आप flight में take off और landing कर रहे होते हो, तब आपको बोला जाता है ना कि भाई आपके phone switch off कर लो. We don't want any radiations to be coming out because they don't want any interference with the communication that they have with the towers on the ground. बिकॉज उनको एक एक पॉइंट की इंफॉर्मेशन करेक्टली पता होनी चाहिए. अगर आप बीच में दूसरे कम्युनिकेशन आने लग गए तो फिर उनके लिए प्रॉब्लम हो जाएगी. तो दे आस्क यू टू स्टॉप ऑल काइंड ऑफ कम्युनिकेशंस.
Okay, sir. So then it means that there is a possible chance that because of some other reason of electromagnetic waves, there can be some interruption in another work or like another use of electromagnetic waves, right?
हो सकता है.
Thank you, sir.
राइट. इनफैक्ट आप लोगों ने मैट्रिक्स मूवी देखी हो तो उसमें ऐसे इलेक्ट्रोमैग्नेटिक पल्स भी यूज करते हैं सो एज टू फ्राई अप सर्किट्स. सब साइ-फाई है. हाँ, सेंटिनल्स. बोलो वेदांत.
Sir, I just said that the radiations are transmitted in discrete units. So can these discrete units be a mixture of separate radiations, or these discrete units are then subdivided into different types of radiations, different wavelengths and
हाँ, because that is what Max Planck proposed ना, that this जो photon है, इसकी energy depends on the frequency. Right? So if you have red light, the red light का photon will have a different frequency versus a blue light का photon will have a different frequency.
So in discrete units they get mixed together.
हाँ, तो चलेगा ना, मतलब even if you have red light, visible light जो आ रही है, which is sum of say all these different radiations, तो अगर मुझे उसका energy लिखना होगा तो it will be sum of the number of photons multiplied by the energy of the type of photon. Right? So यहाँ पर number of blue wavelength photons जितने होंगे multiplied by the energy of each blue photon, and then I will do this for red, for yellow, सबके लिए मैं करता रहूँगा.
So the mixture can have properties different to the specific properties of that color of light.
हाँ.
Okay. Thank you, sir.
ठीक है.
Yes, sir. So light means, if we consider light, the particle nature of light, it is because of the photons present in it, right? So these photons should have some charge inside them.
नहीं. Photons do not have any charge.
So why?
मतलब आपने चार्ज के लिए बेसिस क्या माना? Why Did you even assume that there is
there are the particles, right? So
नहीं,
particles.
तो ऐसा नहीं है ना कि पार्टिकल का मतलब इलेक्ट्रॉन प्रोटॉन न्यूट्रॉन हो गया. Like that is what we come up with this new understanding that there are these elementary particles that we have found around us, right? तो उसमें electron is one type of elementary particle. Like protons and neutrons are not elementary particles. In fact, they are made up of these quarks and leptons, which are elementary particles.
Yes, sir.
Photon is a different elementary particle altogether.
Okay, sir. So elementary particles do not have any charge.
नहीं ऐसा जरूरी नहीं है. Elementary particles don't have any charge. I'm talking about photon as the one which does not have any charge.
So it's neutral.
Yeah.
Okay, sir. Got it.
बोलो Aditi.
So can two different electromagnetic waves affect each other? Like,
वही तो हमने देखा ना, the property of interference.
Yes, sir.
Interference.
Okay, so it can affect each other, right?
Yeah.
So even though a separate electric and magnetic field cannot affect each other, if they are different EM waves, then they can. Okay, thank you, sir.
बोलो Gaurav.
Yes, so last question. I wanted to ask something about, sir, when we say how do I frame this? Like, just a second, sir. When yes, sir, when we say that photon is an elementary particle, does that mean that it is neutral, or like does it consist of any charges inside it, like positive protons or neutrons or electrons? Like, is it neutral in charge, or like is it possible that there can be some charge associated with it in some case?
नहीं. So that is what happens now when we went into.
So we are defining it as a new elementary particle.
Yes.
And it does not have any sort of charge.
No.
Sir, also when we say like, if we are saying a photon has an energy, and it has an energy, like, okay, let's say it strikes a metal plate, and that metal plate, because of excitation of electrons, it releases some electrons because of the energy transferred. Sir, so is it possible that there will be a whole new spectrum of electrons that are being emitted?
मतलब spectrum of electrons.
Sir, as in let's say that for different electromagnetic waves there will be different energy of photons, right? And sir, so when let's say that I'm striking all of them together, so it is possible that there will be a different amount of electrons being released for each wave.
हो सकता है. हम लोग पढ़ेंगे वो फोटो इलेक्ट्रिक इफेक्ट एक्सपेरिमेंट में, वही मैं पढ़ाऊंगा.
ओके सर.
ठीक है. अच्छा गाइस, आप लोगों का 10:15 से यू हैव अनदर क्लास ऑफ मैथ्स. आई होप you understand that you will have to attend that lecture as well. If you are late for that, then आपको वहाँ पे दिक्कत आएगा.
So in the black body radiation experiment, will there be a considerable difference if we use another material?
In the black body radiation what?
Experiment, the graph that we plotted for intensity of the filament of the bulb. So if we use a different material, will there be a considerable difference, or will it show less variation?
Yeah, more or less ग्राफ का प्रोफाइल ऐसा ही रहेगा.
Okay sir, thank you.
मतलब हो सकता है कि पीक किसी और वेवलेंथ पे आ जाए, but the profile would be the same nature. ठीक है. All right guys, आप लोग स्विच ओवर कर जाओ अपने मैथ्स के लेक्चर के लिए. एंड इसमें जो भी रिकॉर्डिंग रहेगा, नोट्स रहेगा, मैं आपके साथ शेयर कर दूंगा, एज वेल एज होमवर्क क्या रहेगा वो भी मैं आप लोगों के साथ में शेयर कर दूंगा. चलो, थैंक यू गाइस, टेक केयर.